Namaste, my friend, and welcome back to JEE Mathematics with Typical Monk. This is class 9, and today the story turns direction. Every trig identity you met in the last class described one snapshot in time, one value, one angle. Today, we ask the opposite question. Given the value, find every single angle that produces it. Here is the surprise. Because sine, cosine, and tangent repeat themselves forever, one small equation is secretly hiding infinitely many answers. When David solved his first trig equation, he found one answer and stopped. Confident he was done. He was only a tenth of the way there. Today, we learn the three formulas that catch every one of the infinite answers. Calmly, one idea at a time. Take a slow breath. Let us begin. So what will you carry home from today's class? First, the three master formulas. The general solutions of sine x equals k, cosine x equals k, and tangent x equals k. Second, the difference between a principal value and a general solution, and why one equation opens into infinitely many answers. Third, how to reduce a messy trigonometric equation down into one of those three standard forms. 4. How to count and restrict solutions so they fit inside a given interval. And fifth, the G drills, a word problem, a match, and a short answer round. So everything you learn today, you can also score with. Ready? One idea at a time. Let us start with the reason behind it all. Sine, cosine, and tangent are periodic functions. They repeat their own values forever, turn after turn. So an equation like sine x equals 1/2 is not satisfied just once. It happens again and again without end. Among all those endless answers, we pick one special one and call it the principal solution. The smallest numerical value, positive or negative, taken from a fixed standard range. G almost always wants more than one answer, so we build the general solution. A single formula, written with a whole integer called n, that generates every root at once. And that letter, n, can be any integer at all, positive, negative, or 0, indexing the entire infinite family in one clean line. Now look at this curve, because it turns the whole idea into a picture. Here is a sine wave and a straight horizontal line marking one fixed value, k. Notice that inside the interval from 0 to 2 pi, the line meets the curve exactly twice. Once at an angle we call alpha, and once at pi minus alpha. Follow the curve further to the right, and the same crossing happens again and again. Every single time we add a full turn of 2 pi, alpha plus 2 pi, pi minus alpha plus 2 pi, and onward forever. One single formula holds both of these branches together. X equals n pi plus minus 1 raised to the power n times alpha. An even n hands you the alpha family. An odd n hands you the pi minus alpha family. And that letter n is free to be any integer at all, positive, negative, or 0. So nothing is ever left out and nothing is ever counted twice. Now let us collect the three formulas that solve every trig equation you will ever meet. First, when sine theta equals sine alpha, the general solution is theta equals n pi plus minus 1 raised to the power n times alpha, one line for the whole family. Second, when cosine theta equals cosine alpha, the general solution is theta equals 2n pi plus or minus alpha, both branches captured together. Third, when tangent theta equals tangent alpha, the general solution is theta equals n pi plus alpha, the simplest of the three, because tangent repeats every single pi, not every 2 pi. And in every one of these formulas, n is any integer, and alpha is just one known solution, usually the principal value you already found. Time to solve a full problem together. Slowly, the monk's way. Solve root 3 tangent theta plus 1 equals 0 for the general solution. Step 1. Write down what is given. Root 3 tangent theta plus 1 equals 0. So isolate tangent theta. It equals minus 1 over root 3. Step 2. Recall the standard value. Tangent of pi over 6 equals 1 over root 3. So pi over 6 is our reference angle. Step 3. Fix the sine. Tangent theta is negative here, so take alpha equal to minus pi over 6 because tangent of minus pi over 6 also equals minus 1 over root 3. Step 4. Apply the tangent formula. Tangent theta equals tangent alpha gives theta equals n pi plus alpha, so theta equals n pi minus pi over 6. Step 5. Write the general solution. Theta equals n pi minus pi over 6 with n any integer. One line holds every single root. Notice the path. Given standard value, fix the sign, apply the formula, general solution. The same steps unlock almost every trig equation G can ask. Now, picture the unit circle itself, because it shows you exactly why the general solution works. The principal value is the one solution we pick from a fixed standard range, usually the smallest angle in size, the very first time the arm reaches that direction. At one full turn, 2 pi, and the arm points in exactly the same direction all over again. The very same terminal point. Keep adding or even subtracting 2 pi again and again, and every integer value of n lands back on that same point without exception. So the general solution is nothing more than the principal value plus the terms. And that single idea is what all three master formulas are quietly saying. Now sit up straight. These 5 lines are what G actually asks year after year. 1. Know the 3 master formulas called sin theta equals sin alpha gives n pi plus minus 1 raised to the n times alpha. Cosine theta equals cosine alpha gives 2n pi plus or minus alpha. Tangent theta equals tangent alpha gives n pi plus alpha. 2. To count solutions inside a given interval, plug in integer values of n one by one and keep only the ones that actually land inside that range. 3. Squatting both sides of an equation can introduce extraneous roots. Roots that satisfy the squared version but not the original. Always substitute back and reject the fakes. 4. Dividing both sides by a common trig factor can silently delete solutions, exactly where that factor equals 0. Split into separate cases instead of cancelling. 5. Produce a messy equation first, factor it, apply an identity, or substitute something like t equals sin x, and only then apply a master formula. Let us drill the G way. I read a claim, you decide true or false, and if it is false, find exactly where the reasoning breaks. First claim, dividing sin theta, cosine theta, equals sin theta by sin theta, gives cosine theta equals 1 as the complete solution. Let us check. Dividing by sin theta throws away every solution, where sin theta itself is 0. So this is false. Dividing by a common factor loses the solutions where that factor is 0. Second claim, squaring sin x equals 1 minus cosine x can never create an extra root that fails the original equation. Think carefully. Squaring is not a step you can undo freely. It can manufacture a root that was never true to begin with. This is false. Squaring can introduce extraneous roots that must be checked against the original equation. Third claim, cosine theta equals cosine alpha always gives theta equals 2n pi plus or minus alpha for n any integer. Check the formula. This matches the master formula for cosine exactly. This one is true. A quick match now. Say each answer aloud before I reveal it. Sin x equals 1/2. The general solution is x equals n pi plus minus 1 raised to the n times pi over 6. Cosine x equals minus 1. The general solution is x equals 2n plus 1 times pi, the odd multiples of pi. Tangent x equals 1. The general solution is x equals n pi plus pi over 4. And sin x equals 0. The general solution is simply x equals n pi. If all 4 came to you before the reveal, general solutions are becoming yours. Here is a favorite G format. I read some statements. You silently count how many are correct. Statement 1. The general solution of sin theta equals sin alpha is theta equals n pi plus minus 1 raised to the n times alpha for n any integer. Hold your verdict. Statement 2. The general solution of tangent theta equals tangent alpha is theta equals 2n pi plus or minus alpha. Think before you answer. Statement 3. Cosine theta equals 1 has the general solution theta equals 2n pi for n any integer. So, how many are correct? Two statements, the first and the third. The sine formula is exactly right, and cosine theta equals 1 truly does give 2n pi. But the second one false. That formula belongs to cosine, not tangent. Tangent theta equals tangent alpha actually gives n pi plus alpha. Two correct statements, 1 and 3. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. Dividing both sides of a trig equation by a common trig factor is always safe. It feels harmless. Just simplifying, surely nothing is lost? But here is the truth. It can silently delete exactly the solutions where that factor equals 0. Always split into separate cases instead of cancelling anything. Myth 2. Squaring both sides of a trig equation never changes the solution set. One operation, surely it leads both sides fairly? The truth, squaring can introduce extraneous roots, answers that satisfy the squared equation but fail the original one. Every candidate must be substituted back and checked, without exception. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ideas you built today. Question 1. What is the general solution of sine theta equals 1? 2n pi plus pi over 2. Question 2. What is the general solution of cosine theta equals 0? 2n plus 1 times pi over 2. Question 3. How many solutions does sine x equals 1/2 have inside 0 to 2 pi? 2. Question 4. What is the general solution of tangent theta equals 0? N pi? And question 5. Squaring an equation can introduce what kind of root? An extraneous one. If you call all 5, you have truly understood today's class. Let us gather the whole class in one slow breath. A trig equation carries infinite roots because sine, cosine, and tangent are periodic. Principal value versus general solution is the whole idea. 3 master formulas. Sine theta equals sine alpha gives n pi plus minus 1. Raised to the n times alpha, cosine theta equals cosine alpha gives 2n pi plus or minus alpha. Tangent theta equals tangent alpha gives n pi plus alpha. To land inside a given interval, generate the whole family from the general formula and keep only what actually fits. Dividing by a common factor can lose roots, split into separate cases instead of cancelling. Squaring can add fake roots. Always substitute back and check every candidate. And next class, we step into inverse trigonometry, arcsine, arccosine, and arctangent, their principal value branches, and how they quietly undo the very equations we solved today. Do not miss it. And so, my friend, we have taken a real leap forward. A single equation just opened into an infinite family, and today you learned to catch every member of that family with 3 calm formulas. Lisa once told me she used to panic the moment she saw an equal sign next to a sine or a cosine. Now she reaches for the right formula without even thinking, because the pattern lives in her, not just on her page. Sarah, David, Lisa, and John all once stood exactly where you are now. Tonight, revise the 3 master formulas once, slowly, out loud. One idea at a time, you will crack G of this, I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you among the inverse functions.